This is Dave. Dave is reading another quantum physics article, and like every quantum physics article, this one tells him that Schrödinger's cat is both alive and dead at the same time. Dave knows this one. Everyone knows this one. It is the most famous thought experiment in physics. Here is what the article does not mention. Erwin Schrödinger made up the cat to mock that exact idea. The cat was supposed to be a joke about how stupid the idea is. He died thinking he had embarrassed everyone. Today, in simple terms, the most famous thought experiment in physics. And the man who invented it because he was, quote, extremely annoyed. Okay. Before the cat. Some setup. At very small scales, electrons, photons, individual atoms, particles really can be in two places at once, or have two energies at once. We are not making this up. We have proved this with electrons, the double slit experiment. You shoot single electrons through two slits and they produce an interference pattern on the screen behind, as if each electron by itself went through both slits at the same time, which is impossible, unless the electron is, in some sense, both options at once, until you measure which slit it actually went through. Then it picks one. Physicists call this a quantum superposition. The particle is described by something called a wave function. The wave function contains both possibilities. Measurement, somehow, picks one. Dave. Okay, so that's the cat thing. Professor, no. Absolutely not. The cat is what happens when you try to take this quantum thing and scale it up. Schrödinger's whole point was that you cannot, which means we have to talk about a furious Austrian physicist in 1935. Erwin Schrödinger discovered the wave equation, won the Nobel Prize in 1933, and, almost immediately, started hating what the other physicists were doing with his equation. His main enemy was Niels Bohr. Bohr ran something called the Copenhagen interpretation, which said, the wave function is reality itself, until you measure. Then it collapses, and the cat picks a side. Schrödinger thought this was insane. He said, if a particle is genuinely in two states until observed, why does measurement do anything special? Why is the observer magical? Nothing in the math gives measurement a special role. Einstein agreed. The two of them traded letters in 1935. Einstein famously wrote, "Do you really believe the moon doesn't exist when nobody is looking at it?" Schrödinger wrote back, "I can do you one better. Imagine a cat in a steel box with a small vial of poison gas. The vial is rigged to a Geiger counter. The Geiger counter is wired to a single radioactive atom. The atom has a 50-50 chance of decaying in the next hour. If it decays, the counter triggers. The vial breaks. The poison releases. The cat dies. Now, according to the Copenhagen interpretation, while the box is closed, the atom is in a superposition of decayed and not decayed. The counter is therefore in a superposition of triggered and not triggered. The vial is broken and not broken, and the cat is alive and dead." Schrödinger's actual point. This is obviously stupid. A cat is alive, or a cat is dead. We do not need to open the box to find out. Reality does not wait for the observer. Cats are not fuzzy. He thought he had embarrassed everyone. He had not embarrassed anyone. Physicists read the cat paper and concluded, Schrödinger had described something deeply weird and beautiful about quantum mechanics. They started teaching it, not as a refutation, as the canonical example. Schrödinger died in 1961. By the 70s, his thought experiment was in every textbook, as an illustration of quantum mechanics, the thing he had spent 30 years complaining about. Today, when you hear someone say, Schrödinger's cat is both alive and dead at the same time, they are stating the position the cat was invented to ridicule. They think they are quoting Schrödinger. They are quoting the people he hated. But here is the thing. Physicists kept asking the actual question. Why can't a cat be in superposition? The math says particles can be. Cats are made of particles. What is doing the work? The answer arrived. Slowly. In the 70s and 80s. It has a name. Decoherence. Decoherence works like this. A particle stays in superposition only while it is isolated. The moment it touches anything else, a stray photon, an air molecule, another atom, the superposition leaks out into that thing. And then keeps leaking, importantly. It does not collapse. There is no magic measurement step. The superposition just spreads into the environment until the original system is so entangled with the rest of the universe that, for all practical purposes, it has picked a side. How fast does this happen? For a cat-sized object, decoherence times are around 10 to the negative 23 seconds. That is a quadrillionth of a second, faster than light could cross a single atom. The cat picks a side before you finish the word pick. The cat is not in superposition. The cat is never in superposition. Not for any measurable instant. The radioactive atom decays or it does not. The Geiger counter triggers or it does not. The cat is alive or dead. Immediately. With no fuzzy in between. Because the moment the atom interacts with the Geiger counter, decoherence destroys the superposition. The cat's fate is sealed at the atom counter junction. The closed box only delays your knowledge of the outcome, not the outcome itself, which is exactly what Schrödinger had been saying. In 1935. He was about 90 years early. He just had to wait for the math to catch up with the part he already knew was obvious. And you are made of particles. Each particle can technically be in a superposition, but you, the macroscopic you, never can. Every air molecule hitting your skin, every photon bouncing off your face, every fingertip touching anything, collapses any quantum weirdness you might have started. Decoherence is invisible, constant. It does not rest. It is the universe's full-time job to keep you classical. You are being collapsed, billions of times per second, by everything you touch and the air you do not even notice. Dave, so all the weird quantum stuff never reaches us. Narrator, correct. Welcome to the rest of physics. So, in simple terms, the cat was always alive, or always dead. The thought experiment was always a refutation, and Schrödinger, somewhere, is still annoyed. The real mystery of quantum mechanics is not that very small things are weird. It is that, somehow, you and your sandwich are not.